So today in this video, as you can see that today we are going to derive the equation for the radius of orbit for the single electronic systems by using Bohr's theory. So now we know that Bohr's theory has also accepted some of the postulates from Rutherford's model of atom, which states that the revolving electrons do not fall into the nucleus because of the attractive force between the two, because the electrons revolving around the nucleus move at high speeds, and because of that they have got enough centrifugal force that keeps a balance of the attractive force towards the nucleus, and as a result the electrons revolve around the same orbit. And this was the postulate which was accepted by Bohr, and it was also incorporated in his theory. And using this postulate only, he just tried to derive the radius of orbit. And today I'm going to derive this equation. So let's see that how this equation is to be derived. So for this, first of all, we'll be we will be we will be taking an atom. This is an atom. Let's do it with another color, like blue. Let's do it with another color. So this is the orbit. This is the nucleus. This is the nucleus with a positive charge. With a positive charge, it can be double positive because it can be lithium plus iron also, but I'm just giving it for hydrogen for the sake of simplicity. Then there be electron. Let us signify the electron with the pink color. Okay, so this is actually an sorry this is actually an atom, single electron system, better to be called as, because we can't call this as an atom, because if this is because if this is lithium, then we cannot say it as an atom, but we have to say that it is actually a single electronic system. Now I said that Bohr has accepted the postulate of Rutherford that the high speed moving electrons have got centrifugal force that is equal to the attractive force between the nucleus and the electron that prevents the electron from going into the or colliding with the nucleus. So we'll be using this postulate only to derive our equation. So first of all, what we know is that let let the atomic number be Z. Let the atomic number be Z. Let me write it with another color. Let it be Z. So let the atomic number be Z. So if the atomic number is Z, then we can write that charge of nucleus charge of nucleus is actually equal to Ze. Now why this is Ze actually? This is because we know that E is the charge of electron. We also know that the charge of proton is also E but with a positive sign. So the total charge of nucleus is equal to the sum total of the charges of all the protons present in the nucleus. For example, if we take a lithium atom and lithium ion, moreover shows that it is actually lithium ion, so in that case it is having 3 protons, so the total charge on its nucleus should be 3 multiplied with 1.6 into 10 raised to the power minus 19 coulomb, because that's the charge of a proton. Where we can also write that where E is equals to charge of a single proton. You should be knowing that P plus is a sign for protons, then E minus is a sign for electrons, and N is the sign for neutrons. So the charge of the nucleus is Ze, where Z is the atomic number of that single electronic system. Now what Bohr's theory states is that the attractive that the attractive force, it is the coulombic, better to be called as, it is a coulombic, that is the attractive coulombic force between between nucleus and between nucleus and the electron is equals to, that must be equal, that must be equal to, let me write it with another color, that is blue. So that must be equal to the that must be equal to the centrifugal force, centrifugal force. So if you have done a bit of physics, you can say that centrifugal force is, the formula for centrifugal force is mv squared by r, where m is the mass of electron, v is the velocity with which the electron is moving, and r is the radius of the orbit. Whereas the attractive force between the nucleus and the electron is k k z e multiplied with e divided by r squared, where r is the distance between the between this proton and this electron. So let the distance between the proton and the electron, which is technically speaking the radius, let that distance be actually r. Let this distance be actually r. So let this so since the distance is r, so we can write that the attractive force between the nucleus and the electron to be actually equal to be actually, sorry, let me write with the orange actually. So attractive force between the nucleus and the electron should be actually then k, where k is the Coulomb's constant, because the Coulomb's constant is a very big value, it's 1 by 4 pi epsilon naught. So who will be writing in that big kind of a thing? So I'm writing k is k z e multiplied with e. So this represents the charge of the nucleus, this represents the charge of electron, divided by the r squared. This is equals to m v squared by r, where m equals to mass of electron, r equals to radius, r equals to radius radius of orbit, and v equals to velocity of electron. Now mv squared by r, so what we get this as that, so what we get our final equation to be kze squared divided by this, from here r will be getting cancelled, so kze squared divided by r is equals to mv squared. Now if you have studied about atomic structure, then you'll be knowing that Bohr in his theory not actually derived a theory, but he just actually gave an hypothesis, which was later on proved by some other scientists that I don't know. But Bohr just gave just an hypothesis that the so just Bohr so what Bohr said is that nh divided by 2 pi is equals to, right in the back color, that is actually equals to mvr, where mvr is the angular momentum, n is the principal quantum number, h is the Planck's constant, 2 and pi you all know. So this is actually the Planck's constant, and this is actually the principal quantum number. So this is actually the principal quantum number. So you must be knowing this theory, that is nh by 2 pi is equals to mvr. Now what we are going to do is that we are going to find the value of v from this equation. So v is equals to nh by 2 pi mr. So from here we have got the value of v, and we will be putting this value of v in this equation. In this equation we will be putting this value of v here. So on putting the value, what will getting this to be, let me do this in a different color, it's quite becoming boring. So mv squared, so what we can write it as that k ze squared divided by r is actually equals to, we can write m multiplied with, now v squared, This means that this whole thing squared, which we're getting as v squared is equal to n squared h squared divided by 4 pi squared m squared r squared. So we can write this to be m into n squared h squared divided by 4 pi squared 4 pi squared m squared, this is again r squared. So from this, if we just do some cancelling, we'll be getting our final equation to be actually gets just getting cancelled, r raised to 1, we are getting this thing. So what we get our final equation to be, something like this. So what we get our final equation to be something like this, that kz square is equal to n square h square divided by 4 pi square m r. So what we have, so this we have got. Now what you do is that we are just going to do some rearrangement here. So if we bring r to here, that is r is equals to n squared h squared divided by k z squared 4 pi square m. So this is the actual equation. This is the actual equation given by Bohr. And so what we can write this to be, that so this implies that r is actually equals to, now you see that what are the variable things, that here the only variables are n squared and z. So we can write that n squared by z whole multiplied with h squared divided by k sorry k e squared 4 pi squared m. And when the scientists calculated, the scientists found out, you can also do this in your home also if you've got a lot of time. So this value comes out to be 0.529. So this value so this value so this value comes out to be r equal to 0.529 n squared by z angstrom. So in the angstrom unit, so this is the radius of the orbit. So if I tell you that what's the radius of the first orbit for hydrogen, hydrogen first orbit what we'll get in this, that r equal to 0.529 into 1 squared by 1 angstrom, which comes out to be 0.529 angstrom. So this is the radius of the Bohr's orbit. This is not actually 4, this is actually 9. So this is the radius. So this is the equation for finding the radius of the orbits for the single electronic systems, and this equation has been found to be absolutely correct. But the main problem with this equation is that this whole equation is only applicable for the single electronic systems. Thank you, and please subscribe my video.